I just wanted to take a moment here to talk about simplifying or reducing fractions. I'm starting with a fairly easy one here, 12/15ths. You may already know how to do it, that's fine. But what I want to talk about is the concept, because people struggle with fractions in general. Understanding how the fraction works and how it's divided up will really help when you're doing harder problems and then with addition as well. So what we want to do is when you're simplifying or reducing, you're actually taking out the common factor in the 12 and 15 and dividing it out. So you're reducing it because those divide out into 1. So what I'm going to do is let's make the prime factor tree of 12 and let's look at what 12 is really made out of. 12 is 2 times 2 times 3. I'm just rewriting it. I'm going to do the same with the 15. 3 times 5. So now I've just rewritten it. I have 12 on the numerator, 15 in the denominator. And now, before we reduce right here or simplify, I do want to look at one other thing right here. If I were to have, say, 9 over 9, we know that this bar here is also the division bar. It means it means division. So we can divide. It says 9 divided by 9. Well, what is 9 divided by 9? 9 divided by 9, numerator divided by denominator, is 1. And that's what we're doing here. We're saying, hey, we know that 9 divided by 9 is 1. It's a big 1. So we can cross it out and we can actually make a numerator of 1 and a denominator of 1, because that's the same as 1. 1 divided by 1. So when we go and look into this fraction here, we're looking for those common fractions, like 9 divided by 9, or 3 divided by 3, right here and here. Since this is all multiplication, I could rewrite it like this. I put the 5 first. And now look, we have a 3 divided by 3, just like I had that 9 divided by 9. And that's what we're dividing out. We're saying, hey, 3 divided by 3 is just 1, so let's divide it out and make a big 1 there. And once we have that gone, 2 times 2 times 1 will just be 2 times 2. And 5 times 1 is just 5. So we've simplified the 3 from the 12, we've reduced it out with the 3 from the 15. You see that? So then the final answer, of course, would just be 2 times 2 is 4 over 5 times 1. It's 5. Get that out of the way. And in the same way up here, we wouldn't need to move the 3's over like this. We could just multiply this out after we reduce the 3's. That's why they cancel. Now you got to be careful. There's a star here. Do not cancel across a plus or minus. Do not cancel or reduce across addition or subtraction. So you can't have any plus or minus signs here. You can have negative numbers, but not adding or subtracting. Okay? Then I can multiply 4/5. So that's the long way of what we're doing. We're looking for the greatest common factor, in a sense, of each of these numbers and dividing it out. If you'd like to see a greatest common factor video, you just can click that and find how to find the greatest common factor of two numbers, and then we just divide that number out of both of them. You can click that video up there on the left. Alright, let's try this other one over here. Erase a little bit of this. We have 24 and 40. We're looking to reduce that. So I'm thinking about the biggest number, the greatest common factor of 24 and 40. If I don't know that, what I can do is just break it apart. Let's break 24 apart. 4 and 6. It doesn't matter if it's 8 and 3 or 4 and 6. The prime factor tree ends the same. And then 40. 4 and 10. Perfect. Now I can rewrite them like this. 2 times 2 times 2 times 3. I like to put them in order. 2 times 2 times 2 times 5. You'll notice that the common factors in here, 2 divided by 2, 2 divided by 2, 2 divided by 2. This in the numerator is actually 8, right? 2 times 2 times 2 is 8, and there's an 8 down there. So if you were to find the greatest common factor of 24 and 40, you would notice that it was 8. And that's what we're dividing out. We're dividing an 8 from each of those. So another way we might write that is just write divide by 8, divide by 8. And then the answer would be 3/5. And that's the same thing I get below here, because each of these 2's divide out. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. Left with 3/5. So a lot of people do this method up here. They just show what they're dividing by, but you want to make sure that you're dividing the greatest common factor, not just one number. Find the greatest common factor and divide that out. Okay, let's have you try one. 64 over 80. You can think about the greatest common factor. You can find the greatest common factor and divide it out. Or you can divide out step by step if you'd want a number. Or you can list it out like I've done. Pause the video and try that, and I'll do it here. Okay, I'm going to do it now. Maybe what I'll do is first here is I'll actually find the greatest common factor. Let's take 64 and 80 and list their factors. This is 8 times 8. This is 8 times 10. So I'm actually going to 2 times 4. Get these all out. This is going to be a little lengthy. 8 goes a long ways. Now if you watched that video previously on the greatest common factor, I circle all the numbers that they have the same. 1, 2, 1, 2, a 2, another 2, one more 2, and that's it. So actually the GCF here is 2 times 2 times 2 is 8, times 2 is 16. So that's the largest factor. So if I divide each of those by 16, I'll actually have the reduced value. I'm going to do it the other way as well. 64 divided by 16 is 4. 80 divided by 16 is 5. So 4/5 is the answer. I'm taking the greatest common factor and dividing it out. Okay, let's say I wanted to do it the way where I just write all the factors out. I have them all right here. They're all at the ends. They're all the branches. I'm going to circle them all in red now. So they're all these numbers here for the 64 and all those numbers for the 80. So I'm going to write them out. 64, 2 times 2 times 2, that's the first 3. And then 2 times 2 times 2 for the second 3. That's 64. Here we have 2 times 2 times 2 times 2 times 5. And then I just go through and I reduce the ones that are the same. That's 1, that's 1, that's 1, and that's 1. So this way is pretty easy. Don't have to remember the GCF method. Same answer. 2 times 2 is 4/5. So either way will work. Hope that helps you.